Good evening all. Now we are going to discuss about the DT based approach of applications of analog and digital communication. You know that there will be 5 stages in our DT. So let me discuss one by one in detail.
Let me tell about empathy. Optical modulation techniques for microwave application is an invitation to understand and appreciate the significance of these often overlooked technologies. It's about recognizing the complex role they play in enabling modern communication systems to function efficiently and reliably. By empathizing with optical modulation techniques, we acknowledge the creativity, dedication, and ingenuity of the engineers and researchers who develop and refine these methods. We see beyond the technical intricacies to appreciate their impact on our interconnected world, where seamless communication is vital for progress and connectivity. Ultimately, it is about fostering a deeper understanding and respect for the contributions of these technologies in our daily lives.
So I'm going to explain about define. The optical modulation technique for the microwave application refers to the method used to encode microwave signals onto optical carriers for transmission through an optical fiber. These techniques involves manipulating the properties of light such as intensity, patch or frequency to carry the information contained in microwave signal. By leveling the advantages of the optical communication such as high bandwidth and low bandwidth, these techniques enables the efficiency and transmission of the microwave signals over a long distance with a minimal degeneration. So they find applications in various fields including telecommunication, radar system, satellite communication and wireless network where high speed, high capacity and reliable data transmission are essential. Moreover, the patch modulation is although widely used technique, whereas the patch of optical signal is modulated through encode the patch variants of the microwave signal. This method offers the high efficiency and provide a performance compared to the intensity modulation. So frequency modulation, on the other hand, involves the modulation in the frequency of optical carriers to convey the frequency variance of the microwave signal. This technique is particularly useful for applications regarding the frequency control and the stability. Overall, optical modulation techniques for microwave application represents a modern telecommunication facilitating the seamless integration of a microwave and optical technique to meet the ever-growing demand for the fast, reliable and high-capacity communication system. Next is IDA.
In the ideal part, an ideal part for exploring and innovating within the realm of optical modulation techniques for microwave applications are hybrid modulation schemes, explores the development of novel modulation schemes that combines the elements of intensity, space and frequency modulation to optimize the performance metrics such as data rate, signal to noise ratio and spectral efficiency. Next, non-linear optical effects will investigate the utilization of non-linear optical effects such as four-way mixing and stimulation, Bernoullian scattering. Next, integrated photonic circuits explore the design and fabrication of integrated photonic circuits, incorporating the optical modulators and amplifiers and reductance. Next, quantum enhanced modulation technique will explore the use of quantitation technologies such as quantum enlargement and quantum communication protocols to enhance the performance and security of optical modulation techniques for microwave application. Next, biologically inspired modulation concept that draws the inspiration from biological systems such as neural networks and genetic regulatory networks to develop the novel modulation concept based on principles of self-organization, adaptation, and robustness, enabling the autonomous and self-healing optical modulation systems. And then environmental sensing application that explores the use of optical modulation techniques for microwave application in the environmental sensing applications such as remote sensing for atmospheric parameters, the detection of chemicals and biological acids, and monitoring the environmental pollution, leveraging high sensitivity and immunity to electromagnetic interference of optical system.
Let me go into tell about prototype. Prototype for optical modulation techniques for microwave application involves integrating optical and microwave components to demonstrate the transmission and reception of microwave signals over optical fibers, demonstrate the transmission of receptions of microwave signals using optical modulation techniques. Components used are microwave signal source, optical modulator, optical fiber, optical receiver, microwave receiver, controlled power supply. Showcase the transmission of high speed microwave signal over optical fibers, demonstrating the superior bandwidth and data rate capabilities of optical communication. Highlight the low latency performance of the system, showcasing its suitability for application requiring real-time data transmission and communication such as wireless network and radar system. Implement adaptive modulation techniques to dynamically adjust the modulation parameters based on changing requirements of the transmitted data, demonstrating the flexibility and the efficiency of the system. Stress test the prototype under various environmental conditions such as temperature fluctuations and electromagnetic interference to showcase its robustness and reliability in challenging operating environments. By showcasing the seamless integration of optical modulation technique with microwave applications, this prototype demonstrates the potential of microwave photonic of revolution communication system in various industries.
Then I am going to explain about the final step, testing. Verify the basic functionality of the optical modulation system, including modulation, demodulation processing, signal generation and transmission reception capabilities. Measure the signal to noise ratio and bit error ratio of the transmitted microwave signal at a different modulation schemes and frequencies. Measure the latency of the optical modulation system by comparing the delay between the transmission and the reception of the microwave signal over optical fibers. Test the compatibility and interoperability of the optical modulation system with other communication devices, protocols and networking infrastructures. Perform field tests in real-world deployment and scenarios to validate the optical modulation system performance, reliability and usability under practical operating conditions. Then gather feedback from end